Greetings, grade 12 learners, and welcome to Get Smart with Stanford, where learning gets simpler, smarter, and sharper. Learn better, achieve more. Today, we are unlocking one of the most important grade 12 math topics, that is functions and graphs. We will explore how to sketch, interpret, and understand beautiful patterns behind equations, from parabola, hyperbolas, straight lines, and exponentials. This lesson is proudly brought to you by Mabarula Trading and Projects, suppliers of animal feeds and bulk tissue products. We supply all kinds of chicken feeds, pig growers, and dog food designed to keep your animals healthy and strong. When it comes to tissues, we've got you covered too, offering single and double ply virgin paper as well as single ply recycled tissues. We are all about quality and reliability. And just to be clear, we do not sell pre-owned tissues. We are located in Bakersford, Gasilala, next to R37 Road. You can contact us on the following details as they appear on your screen. Now, let's get down to it. Functions and graphs. Look at the statement of the first question. The sketch below shows the graph of f of x equals minus 2x squared minus 5x plus 3, and the graph of g of x equals ax plus q. The angle of inclination of graph of g is 135 degrees in the direction of the positive x-axis. P is the point of intersection of f and g, such that G is a tangent to the graph of f at point P. In question 1.1, we are required to calculate the coordinates of the turning point of the graph of f. I am going to show you two options to help us get the answer to these questions. First, let us apply the derivative method. We will differentiate the original equation to get f prime of x. And the f prime of x equals minus 4x minus 5. Equate this to 0. We are equating to 0 because the slope of the gradient at turning point equals 0. And the value of x in this case equals minus 5 over 4. The second option would be to use x equals minus b over 2a. We know that as the formula for the turning point. Now we substitute the values of b and a from the original equation, where b is minus 5 and a is minus 2. We have minus 5 over 4, which is the same answer as the one we got when using the first derivative option. Now let us substitute minus 5 over 4 into the original equation to get the value of y at the turning point. And the coordinates are minus 5 over 4 and 49 over 8. There is of course a third option which I did not include in this video. That is taking out the common factor of minus 2 from each term. Then factorize. You will get the same answers as those that we got before. In question 1.2, the examiner wants us to calculate the coordinates of P. That is the point of contact between the graph of f and g. Given the angle 135 degrees, we can calculate the gradient or the slope. Gradient and slope is one thing of the straight line, which is minus 1. Equating the gradient of minus 1 to the first derivative, we'll find the value of x to be minus 1. We equate to the first derivative because the contact point is at the turning point. Now we substitute that to the original equation. and the value of y at the point of contact is 6. The coordinates at the turning point P are -1 and 6. In question 1.3, we are instructed to determine the equation of G. Since we have the gradient and the values of x and y at the contact point, we can use the equation of the gradient. Substitute the values that we know and apply basic mathematics. Here is the equation of G, which is the straight line. Y equals -1x plus c. In question 1.4, they say determine the values of D for which the line k of x equals -x plus d will not intersect the graph of f. We know the value of x, which is -1. If it is substituted to this equation, we will have 1 plus d. We already know that the value of y at the contact point is 6. When we substitute 5 to d, we will get 6, which does not suit the equation because it intersects the parabola. This tells us that all the values of d that are greater than 5 will give us values that are greater than 6. And that suits the equation since the straight line will move up and no longer intersecting the graph of f. You can also apply the trial and error method. You substitute the values from maybe 0 to 10, and you will see that from the moment you substitute the values that are greater than 5, the graph of G does not intersect the graph of F. Now we are moving to question 2. We have the function of x equals 2 divided by x plus 1. And from that fraction, we subtract 3. In question 2.1.1, we are instructed to calculate the coordinates of the y-intercept of the function. We already know that for y-intercept, our x is equal to 0. Therefore, we substitute x with 0. Then the value of y is -1. So we have the coordinates 0 and -1. In question 2.1.2, we need to calculate the x-intercepts of the same function. Since we already know that for x-intercept, y equals 0, we then equate the function to 0 as it is on the screen. Next, we transpose -3 and then multiply both sides by x plus 1. This gives us x to be minus a third. A third is 1/3, so it's -1/3. Our coordinates are -1/3 and 0. In question 2.1.3, they say we must sketch the graph of f, showing clearly the asymptotes and the intercepts. From the original equation, we can see that the y asymptote is -3, which is the horizontal asymptote. To find the asymptote of x, we take x plus 1, the denominator. We equate x plus 1 to 0, where x equals -1, which is the vertical asymptote. And this is the required sketch. Look at it carefully and compare to whatever it is that you would have done and do some corrections where necessary. 2.1.4, they want us to write down the equation of this axis of symmetry for which the function is decreasing. Remember that the general equation for the hyperbola function is a over x minus p, and q is subtracted from that fraction. The vertical asymptote here is x equals p. and the horizontal asymptote will be y equals q. Looking at the axis of symmetry on the Cartesian plane, the one that rises from bottom left to top right has a positive slope, and the one that decreases from top left to bottom right has a negative slope. With that given information, or with that information revealed to us, then we learn that the gradient required in this question is negative, or -1. That is the decreasing slope. Now looking at the equation of the gradient, which is y minus y1 equals m into x minus x1. Let us substitute the known values into this equation, and we'll find that the equation is y equals minus x minus 4. In 2.2, they say the graph of an increasing exponential function with equation f of x equals a times b to the power x plus q has the following properties. The range, which is y is greater than -3, and the points 0 and -2, and another point 1 and -1 lie on the graph of f. 2.2.1 says determine the equation that defines f. From what we've been given, we know that in the first point the value of q is -3, x is 0, and y is -2. If we plug those values, then a equals 1. In the second point, the range is still the same, -3. X is 1 and y is -1. We find the value of b to be equal to 2. Plug those values to the original equation, and the function of x will be equal to 2 to the exponent x, and 3 is subtracted from that. That is what is required of us. In 2.2.2, they want to know the transformation that has occurred. Here we have the vertical stretch where the base of the exponent has changed from 2 to 2 multiplied by 2. The graph becomes steeper and increases rapidly. That means it increases quickly or faster. We also have the vertical shift where the constant changes from -3 to +1. The graph in that case has moved up by 4 units. And that is basically what is required in question 2.2.2. In question 3, they say the graph of g is defined by the equation g of x equals square root of ax. We are also given the coordinates of the point that lies on the graph of g. In 3.1, to calculate the value of a, we simply plug in the values of x and y from the point that is given. To get rid of the square root, we square it. That basically means we are raising it to the exponent 2. We do this because the square root means you are raising whatever that is under the square root to the exponent of half. So if you raise everything there to the exponent 2, that means you are multiplying that half, which is the square root, by 2. And half times 2 equals 1. That is how we remove the square root. So what is done on the right hand side needs to be done on the left hand side as well. That means since we have squared the right side, we need to square the left hand side. And the value of a equals 2. In 3.2, they want to know what values of x will define the function of g. If g of x is greater than 0, 0 and all positive values will suit this equation. And g will be defined by all those positive values. Negative values will be undefined. That is simply because we do not have a negative square root. You can put any negative number, no matter how small or big it is. You can put a square root of negative 1 million, square root of negative 1,000, square root of negative 1. They will all give you the same answer. It is undefined because we do not have a square root of a negative number. 3.3 wants the range of g to be determined. The smallest value of g of x is 0, and that is when x is equal to 0. And it increases without bound. With every positive value that you plug in, it will continue increasing. Therefore, y is greater or equal to 0. And this also happens because the inverse function of this equation gives us the square root of ay. And then all the values that will be in there need to be positive because we do not have a negative square root. And question 3.4, to find the inverse function, we simply swap the positions of x and that of y. To remove the root, we raise both sides to the exponent of 2. And to arrange the equation as per the instruction, because we've been given an instruction in the initial statement to say we must write the inverse function in the form y equals something. So we divide both sides by 2. And our inverse function of g equals half x squared. 3.5 says, if h of x equals x minus 4 is drawn, determine algebraically the point or points of intersection of h and g. To determine algebraically means you must find the answer using equations and algebraic manipulations, not by guessing, not by estimating or using any graphs. In other words, you must set the two equations equal to each other and solve for x and y using algebra, not by looking at the graph and estimating. So let us use algebra to determine the points of intersection. We will start by equating the two functions. Equating, I mean putting the first function and saying it is equal to the second function. We are doing this because at the point of intersection, that is where the two graphs come across each other, or that is where the two graphs meet each other. And at that particular point, the graph of h equals the graph of g. We will start by equating the two functions and then remove the square root by squaring both sides. And then we will multiply this expansion. We transpose 2x from the left hand side to the right hand side and equate to 0. Then factorize. X equals 8 or x equals 2. When we substitute these values of x on both equations, we must get the same values of y. When x equals 2, we get 2 on the left hand side and minus 2 on the right hand side. They are not equal. Therefore, x equals 2 is not applicable, because when we substitute on both sides, we are not getting the same value. But when x is equal to 8, we get 4 from both sides. You can substitute on your own on the left hand side and the right hand side. You will see that you are getting 4 on the left and 4 on the right. That means to you these two graphs, the graph of h and the graph of g, are equal at x is equal to 8, because when x is equal to 8, they are equal to 4. Therefore, our x is equal to 8 only. This means that we are only considering the value of x to be 8, because that is where both graphs are equal. That is where both graphs are intersecting each other. And the last question, which is 3.6, they want us to determine the value of x for which g of x is greater than the function of h of x. From what we calculated at question 3.5, the graphs are equal at x is equal to 2 and x is equal to 8. Anything above 8, then the graph of g will be less than the graph of h. You may perform trial and error by substituting values from maybe minus 1 to 10 to practically prove this. You will see that from any value that is bigger than 8, then the graph of g will be less than the graph of h. And that's it for today's lesson on functions and graphs. I hope this lesson helped you to understand how to analyze, sketch, and interpret functions with confidence. If you found this video to be helpful, don't forget to like, subscribe, and share it with your friends, your classmates, and anyone who may seek understanding in mathematics, especially functions and graphs. Because learning is always better, and it is better when you do it together. If you have any questions, topic requests, or any suggestions, you can send them straight to me on WhatsApp or email, or you can drop a comment on this video. I'd love to hear from you and feature your ideas in our next video, because your opinions are valued here at Get Smart with Stanford. Remember, get smart with Stanford all the time. Learn better, achieve more. See you in the next video. Thank you so much.